All right, everyone. It's time for the second discussion, which is data types and signatures. Now, one of the key hurdles in when coming from non F sharp world or non functional programming world to F sharp is the function signatures. It can be extremely irritating. It can be extremely difficult to get a feel for function signatures. It takes quite some time. So, what I can recommend is be patient, be slow. Slowly, it will make sense why the odd-looking function signature or signatures are the way they are. So the goal of this particular discussion is to introduce you to the basic types because F sharp is a very rich and comprehensive type system. More so because it's based on .NET and has to support the classes, etc., etc. But I'll not get into classes. I'll just talk about the very basic data types and the basics of function signatures, because you have to, sooner or later you have to get friendly with function signatures. Now, one important thing, when you're working in F sharp, everything is a value. Everything is essentially a value, whether you're writing a function, whether you're creating a so-called variable as we do in C sharp, C, etc. Everything is a value. So out of habit, I may call something a variable, I may call something a function and whatnot. But end of the day, in F sharp, the way F sharp compiler deals with things, or the way F sharp is designed and it operates, everything is a value. Secondly, values are assigned to names, and names with a leg binding like this. When x is bound to this value, x becomes an immutable thing. Simply means that you cannot change x, and that is exactly what immutability is about. That once something is assigned to a name, you cannot change the value that is assigned to that name. And this is where things get super duper tricky. Rather, I mean, when I heard for the first time, when I heard this concept, I couldn't figure out how programming can be done with immutability as a restriction. But it's a slow process. It requires a different approach. It's a different thought process, and we will see how it works. So here are various data types. You have integers, and before I go into more examples, F sharp is statically typed. It's a very strict language when it comes to type system. But what compiler does for you is it takes care of inferring types a lot of times, which gives a false impression that F sharp is either loosely typed or everything is generics. And both those statements are absolutely incorrect. F sharp is strictly typed. Everything that you are writing is boiling down to some type. In certain cases, it gets down to generic types, but those are for later discussions. So when you assign a value to something, F sharp compiler does a hard job of figuring out what the type is. And in most of the cases, the compiler does a decent job. In some cases, you will be forced to annotate the 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 type declaration, etc. Otherwise, you will run into all sorts of crazy compiler messages, which a lot of times makes no sense. Make no sense. So this is how you declare integers. Integers are 32-bit signed integers. That's what an int is, an int 32. This is how you deal with bool values. The data type is bool with only two possible values, bool and false, true and false. This is 8-bit integer. This is the unsigned. This is the signed one. Then you have 16-bit unsigned, 16-bit signed. You have 32-bit signed and unsigned. You have, I think this is a typo, this should have been 64, 64. These are 64-bit integers. And this is 32-bit floating point value, also known as a single. This is slightly confusing because in nearly all the other languages that I know of, a float is a 32-bit single value. But in F sharp, a float is a 64-bit floating point value. Float and double are synonymous in F sharp. Float 32 and single are synonymous in F sharp. This is a 32-bit floating value, and this is a 64-bit floating value. 64-bit gives you more precision. It occupies more space. As simple as that. And this is a Unicode character. In case there is any confusion on what a Unicode character is, I'll perhaps dedicate a different piece altogether, because this seems to be a perpetual perennial confusion for a lot of programmers, what Unicode is, what UTF-8 is, what UTF-16 is. So because F sharp is based on .NET is essentially, Windows essentially is based on UTF-16. So when you say a char, you are dealing with UTF-16s. A string is, a lot of UTF-16 values. And now comes this craziness called unit. And that's because a unit has no real parallel in imperative programming world. A unit means just one value. There is no multiple values possible for unit. And this is how you denote a unit, an opening and a closing bracket. This is very, very confusing because this is similar to a function call. If it was X, this resembles a function call in C and derivatives, but this is a unit. A unit means universally single value of type unit. The data type is unit, the value is this. For instance, if you have a function which returns an integer, you'll return an integer. If a function in the C world, if it returns a void, it can't return a void. There's no void in F sharp. You will return a unit, which is denoted by this. So more and more, slowly you will understand how unit fits into the biggest, the larger scheme of things. But unit is very, very loosely, cheaply put. Unit is what a void is in C, but that's not true. It's misleading actually. Now here is a function which is let let binding, because like I said, everything in F sharp is a value. So if you roll your mouse over, you see val. It's not saying function, it says val and a fancy signature. If you roll your mouse over this, it says val and a value and a data type. If you roll your mouse over here, you see a val. If you are doing it with the function, you see val, because end of the day, everything in F sharp is a value. You are not dealing with anything other than values. You create values and you assign, you bind names and values. That's what a let binding is. There is a mutable binding also known as let mutable something, but I'll talk about it in a little while. So this is how you create a function. This is let binding, function name, parameters to the function equals to followed by the body of the function. And if you remember from the last discussion, whatever is the last expression in the function becomes the return value. So add two nums v1 v2, same function written differently, is nothing but a function which takes two parameters and returns the sum of those two values. Now I said earlier that F sharp compiler does a heavy duty job of type inference. So these two are absolutely same. In one case, I'm letting compiler do whatever the compiler has to do to figure out the types, and in this case, I have done the hard job of declaring that X is an integer, y is an integer, and this colon, which is after all the parameters, is the return value type of the function. So these are absolutely same. Now the signature of this function is int arrow int arrow int. The first int is for this parameter, the second int is for this parameter, the third int is for the return type, because x plus y returns an integer as x and y are integers. So the function signature of add to nums v1 is int, which you can see if you roll your mouse over. It says x is an int, y is an int, and which returns an int. Now, like I said in the beginning, this notation style is extremely problematic and irritating and difficult to learn and master. So let it happen. Let it come to you, whatever time it takes. But it'll make sense. So whenever you see a function, look for the last arrow. That's the return type of the function. Anything which is before the last arrow is the list of parameters. In F#, you can't have a function with no parameters. That's something you cannot have. Just like you cannot have a function returning void, you cannot have a function which does not take any parameters. You will have at least one parameter, and you will definitely have a return type. That's the minimum meat you will have in a function. Here is another function which give this function anything, and this function does it toString. toString is a function which is borrowed from the .NET library, because in .NET everything is an object, just like Java, and object has a method called toString. So no matter what you are dealing with in .NET will have a .toString function. Similarly, whatever you are dealing with in F# will have a toString function. So anything toString v1, which is without any type declaration, it says give me anything, I'll give you the string of it. And then I have a type annotated version of it, which is exactly copy of the previous function with types indicated. Is that anything, and this tick A. Tick A is for generics. Don't pay too much attention to it right now. This is just to give you a feelers of what the signatures in F# look like. So the signature of this function is give me anything, I'll give you a string. That's all it does. Then there's another function which is toUpper, which is give me a string here, and I'll give you back a string. Now if you may wonder why I don't have this function written like this. Why even in the first version, unlike the other examples, I have annotated the parameter with type, is because I need the toUpper function available. I cannot call the toUpper function unless I declare that any string parameter is a string. Now this is the extreme case example, which is if you look at the signature of this function, it's a unit to unit. And this function takes one parameter of type unit. Remember I said unit type has only one possible value indicated by this pair of brackets. This function has one input parameter which is of type unit, and it returns a unit value. This is useless. This is just to give you an example of all the possibilities you will have to deal with in future. This is a function which takes no parameter, again returns a unit, because this is a side effect function. This is just printing out current date time, but this is also a unit to unit function. And this is another example of whatever number you given, that number is printed out, and this function has nothing to return, so it's returning a unit. But the signature of this function is int to unit. Give me any number, I'll print that number and return a unit. Int to unit. Righto? So I'll quickly see if I have not, let me just check if I have covered everything. Yeah, and I'll recommend that read the notes that I leave on the blog, because I spend quite a lot of time writing the notes on the blog. It's a long process. I write those, rewrite those, read those to make sure that I have not missed anything. So if during the videos, in case if I have missed anything, you can always go to the blog and check. We missed let mutable declaration, but the basic idea is that, though highly not recommended not to use this, you can do this. Now what you are saying is that this value is assigned to this name, but you are saying that this name, you can change its value. So the odd syntax in F# is this. You can't say this. This will not work, because this in F# is equality operator. This is not assignment. Assignment can only happen with a let variable name equals to binding, or a let mutable binding. So if you need to mutate something, if you need a variable or a name for which you are changing the value over the course of a function, you need to have a let mutable binding, declare the variable and change the value like this. But like I said, you will need this in extremely rare cases, something which is very difficult to imagine, that how is it even possible to write code without immutable variables, but it'll come to you. All right, that's all for this lesson. See you in the next one.